Okay, so in this video we're going to go over solving quadratic equations. Last time we looked at linear, and so now just moving to equations to the second power. And there's four different methods that we'll use using square roots, factoring, completing the square, and the quadratic formula. So four of these that you need to be familiar with. Now, quadratic equations in general are when we have a variable to the second power. For instance, y equals x squared. There's other ways of, there's a general form, which would be like y is ax squared plus bx plus c. And so I might be using some verbiage in here. This is called the linear term. Why is it linear? Because it's to the first power. This would be our quadratic term. Why is it quadratic? Because it's the second. And since there's no variable on this one, that's called the constant term. And those capital A, B's, and C's, those are called parameters. So those have a special name. So those are parameters. And so that's typically where you'll see your numbers. But we'll use these, the A, B, and C, for both completing the square and the quadratic formula. Now, depending on the form, that kind of dictates what method you can use, although the quadratic formula works for all of them. So the first one we'll look at is just taking square roots. And so this is when you only have your quadratic term. So there's no linear term. So if you just have a quadratic term, then we'll be able to just take the square root. So in this case, again, looking at this, I'm going to solve for x, so I have it underlined. So I can see there's an x squared, and as I scan through, there's no linear term, there's no x. All I have is a constant and then this other thing with variables. And so I can just solve for this using, just like I would with a linear equation, opposite inverse operations. So we'll move this term first. So we're going to subtract the 4y squared minus 4y squared, leaving 3x squared is equal to 9 minus 4y squared. And then this is a multiplication, it's 3 times, so we're going to divide by 3 all the way across, so remember to do it to everything. So we get x squared is equal to 9 divided by 3 is 3 minus 4/3 y squared. And then to get rid of the square, we're going to do inverse. The inverse of a square is a square root, so we just take the square root to the other side. So it's going to be the square root of 3 minus 4/3 y squared. And that's it. That would be my solution. So go ahead, pause the video, try this one, do it for y this time. Okay, so to solve for y here, again, we're going to just move stuff. We're trying to isolate the y, so we'll move the 3x squared over to the other side, leaving 4y squared is 9 minus 3x squared. Divide everything by 4. And we get y squared is equal to 9/4 minus 3/4 x squared. And to get rid of this square, we're going to take the square root on the other side. Oh, I'm sorry, one thing I forgot. So when you take a square root, you're going to have a plus or minus. There's 2 roots here. So this is plus or minus, always. Square root 9/4 minus 3/4 x squared. And the reason that we have this is because the number of solutions to an equation is always the power minus 1. Or I'm sorry, it's whatever the power is. So since this is quadratic, it's the second power, so we'll have at most 2 solutions. Sometimes you'll have 1, sometimes you'll have 0, but at most 2. So we're typically looking for 2 solutions if it's a quadratic, whereas linear will just have 1 solution. So the plus minus takes care of my 2 solutions. Okay, that's just taking square roots. Okay, so what happens if you do have a linear term? Well, if you just have a quadratic term and a linear term, then we can use factoring. There is a more complicated factoring. I'll kind of talk about it after we do these 2 examples, but I really don't use it all that much. I would just use the quadratic formula. So to use factoring, we need to get it needs to be in the form of equals 0. So we're going to have to move this term over here. So we're going to subtract the 4x, subtract 4x. Keeping in mind these are not like terms. So we get 3x squared minus 4x equals 0. So once I have it in this form, now I can either factor it or use the quadratic formula. You'll see this pops up again. So what I'm looking for is things in common. So my common factors here is just an x. It's one x. So what I'm going to do is I'm going to pull out an x, and then I leave whatever's inside. So that would be 3, and x times x is x squared, and x times negative 4 is negative 4x equals 0. So what you can see is I just removed an x from each term and pulled it out front. Now at this point we break it up. So we're going to have x equals 0, because that's this part, and we have this part equal to 0. So 3x minus 4 equals 0. Well, there's one of them, so there's one solution. The other solution's in here. So now you can see it's just a linear equation that we solve. So we'll just do a plus 4 on each side. So 3x equals 4, divide by 3, and x is equal to 4/3. So there's your two solutions. So go ahead, pause the video, try this one. Okay, this one there's a couple different ways you can do it. Like you might just divide. I see there's a 6 and a 12 there, so maybe I'll just divide that off. But I'm going to follow this method because that's probably what you did. So subtract 12x to the other side. So we get 6x squared minus 12x equals 0. Now in this case I have an x in common, but I also have a 6 in common. So I'm going to pull out a 6. If you didn't do it this way, it's fine. As long as you follow rules of algebra, you'll be okay. 6x times x gives me 6x squared, minus 6x times 2 gives me 12x equals 0. Again, we break it up, so I'm going to get 6x equals 0, and x minus 2 equals 0. And now we solve each equation. If we divide by 6, 0 divided by 6 is 0. So that's one of them. And then we could just add 2 to the other side, and x equals 2. So those are our two solutions for that equation. Now, I did mention these are pretty simplistic factoring, and so when you see just a quadratic and a linear term, it's nice. You just find out what's in common, makes it easy. There are more complicated factoring problems, like x squared, let's do plus 8x plus 16 equals 0. So this one we can't do it like this because I have this constant term, this c term over here, and so it wouldn't work, because if I move that over, it's going to be equal to negative 16, and I said to do this we have to have equal to 0. So what we're going to want to do here is actually factor it into binomials, and this goes where you have these two binomials like that. And what we look for are two numbers that multiply to give me this. So they multiply to give me this, and they add up to be this. And if I can find two numbers, they just go here. So I can see 16 is 4 times 4, and 4 plus 4 is 8. So this is 4x plus 4, x plus 4 equals 0. And then from this point on, it's the same. So x plus 4 equals 0, and x plus 4 equals 0. You can see that it's the same. This only has one solution. So x equals negative 4. So that's the more complicated, and then it gets a lot more complicated than that, but not in this class. We're not going to be doing this heavy factoring. Completing the square. So this is a technique when you can't factor. So like here, it works best if this is even. It doesn't have to be the case, but it makes it pretty clean if it's even. If it's odd, it still works, but you're going to have a bunch of fractions. And then basically what we're going to do is we're going to move the c term over here so that it's not equal to 0. So we'll do that first. So we're going to subtract 5. So we get x squared minus 8x equals negative 5. Okay, so the first step is just to get your quadratic and linear term together. And then what we're going to do is we're going to do this thing. We're going to add b over 2 plus b over 2 squared. So remember, this is like A, this is B, and this is C. So we move C over, and then we're going to take this and we're going to add it to each side. So it looks like this. We're going to have x squared minus 8x, and then I'm going to leave some space, so negative 5. And what we're doing is we're going to add plus b, which is 8, it's actually negative 8, over 2 squared. And whatever I do to one side, I have to do to the other side. So negative 8 over 2 squared. And now we can simplify. So I'm going to get x squared minus 8x. 8 divided by 2 is 4 squared is 16. So plus 16 equals, again, that's 16. So equals 11. Now the reason that we do it is because of this right here. When we do this little trick of adding b over 2 squared, it gives me what's called a perfect square. So it's similar to the example that I gave you up here. This is a perfect square, so it comes out to x plus 4 squared. So this is easy to factor. This is just going to be x, and since that's negative, it's minus 4 squared is equal to 11. And now to get rid of the square, we just take the square root to the other side. So x minus 4 equals the square root of 11, plus or minus. And now I can just move the 4 over. So x is equal to 4 plus or minus the square root of 11. So go ahead and pause the video and then you give it a try. Okay, so I'm going to go pretty quickly through this one. Same thing, we're going to move that c over. So we're going to end up with x squared plus 12x equals negative 4. I just moved that over. And then we're going to do, we're going to add on b over 2 squared. So this is going to be plus 12 over 2 squared. And then plus 12 over 2 squared. You got to make sure you do this other side. So that'll be the biggest error. You only do it to one side. But remember, it's algebra. Whatever you do to one side, you got to do to the other. So this is x squared plus 12x plus 12 divided by 2 is 6 times squared is 36 equals negative 4 plus 36. So again, I've just added the same quantity. But now we have a perfect square on this side. 6 times 6 is 36, and 6 plus 6 is 12. So we get x plus 6 squared is equal to 32. Again, taking the square root, we get x plus 6 equals root 32, plus or minus. So x is equal to negative 6 plus or minus the square root of 32. And there's your two solutions. Okay, the last method that we'll look at is the quadratic formula. So when I have an equation like this, where y is ax squared plus bx plus c, and y I then set to equal to 0, so I'm finding the roots, then I can use the quadratic formula. Now keep in mind, this applies to all quadratics. Doesn't matter what it looks like, this will solve it. So this always works. These other ones, they're special cases. This is the general formula. So I really recommend when you work with quadratics, just be comfortable with this. Now, there are points where the other methods come into play and are easier to work with than the formula, but in general, this will solve everything. So the idea is we need to get this in the form of all of this equal to 0. So we're going to add 4x, the linear term, over to the other side. So 2x squared plus 4x equals 3. And then we move the 3, so minus 3. So 2x squared plus 4x minus 3 equals 0. So now I can see that this is, I have my ABC. So this is A, this is B, this is C. Make sure when you're doing this, the negative goes with the number. And now we'll just apply it in the quadratic formula and solve. So using the quadratic formula, I get x is equal to negative b. B is 4, so we get negative 4 plus or minus the square root of b, which is 4 squared, minus 4 times a, which is 2, times c, negative 3. Now if you don't bring that negative, you would get a non-real result. You get a square root of a negative. So be careful. This is 2 times 2. A is 2. So, and now it's just a simplification. So negative 4 plus or minus the square root of 4 squared is 16. There's a negative here, but there's a negative there, so it's going to become positive. And we get 4 times 3 is 12 times 2 is 24. Divided by 2 times 2 is 4. So x is equal to negative 4 plus or minus the square root of 40 divided by 4. And yeah, I mean, that's an answer. You could plug that in a calculator and get a number. Keep in mind it's plus minus. I'm going to break it up though. So when we have fractions like 2 plus 3 over 5, keep in mind that we can always break it up. That's the same as 2 over 5 plus 3 over 5. Because this is just how we add fractions with common denominator, so you can go backwards. And so this is negative 4 over 4 plus or minus the square root of 40 over 4. The reason I did that is because now you can see that's negative 1 plus or minus Root 40, that's 4 times 10 inside. Square root of 4 is 2, so 2 root 10 divided by 4. And then 2 divided by 4 is 1/2. So you see you can just keep simplifying it. 1/2 square root 10. And I think that's good. I had this other example, but this video is run long. So you can find plenty of practice on quadratics, but we'll be doing some in class. So there you go.